Scholar's breakfast. All right. Ready? Okay. Number 1 is 1.1. Oh, come on. Gentlemen. 1.1 times 10 to the negative 2 meters. B is 7.62 times 10 to the negative 11 meters. C is 2.1 times 10 to the 3 meters. D is 1.23 times 10 to the 5 meters. Number 2A is 1.47 times 10 to the negative 1 kilogram. B is 1.1 times 10 to the negative 8 kilogram. C is 7.23 times 10 to the 3 kilograms. D is 4.78 times 10 to the negative 4 kilograms. Number 3A is 4.23 times 10 to the negative 1 meters. B is 6.2 times 10 to the negative 12 meters. C is 2.1 times 10 to the 4 meters. D is 2.3 times 10 to the negative 5 meters. E is 2.14 times 10 to the negative 4 meters. We're going to breakfast?
Yeah. Oh, I'm coming from it.
You're coming because they already called the seniors down. Okay. Okay. Oh, you're done with breakfast?
Yeah.
Okay. And then F is 5.7 times 10 to the negative 7 meters. And that's the homework. You want to go over any of those? Any questions before you start the quiz? Okay, you may use your homework. You will need your reference table. You will need your calculator in the SCI mode to do today's quiz, where there are 3 questions. Good luck. It's on your Chromebook. Should be no talking. Quiz for Unit 1D is what you're looking at. When you've completed your quiz, you can put your Chromebook away. Once you've completed the quiz, you can actually pack up your Chromebook. You won't be using it for the rest of our class period. Unless you need to write a pass to the restroom, but usually we go during the break, so that doesn't require a pass. Lisa? I'm going to get started on the next section though. Okay, so your homework for Monday is page 12. Page 12 in your packet. Okay, so you can make a note of that. Page 12. is your homework for Monday, where I'm asking you to algebraically solve the equations that are listed on that page. There's plenty of room for you to do that on the page. You're not going to do it in your notes. You're going to do it on the page. And I want you to show your steps to get to the final solutions. Today, we're covering two topics. This period, we're going to cover the topics that you need to do the homework this weekend. Algebraic manipulation. We'll take a quiz on that on Monday, where you will have to show me how to algebraically manipulate 3 different physics equations. And then we're going to tackle something that we need to help us finish Lab 1, which is the problem-solving method that we use throughout this course. It's called the GUESS method. And we'll be learning how to use that and our reference tables to solve about 65% of the questions on your physics Regents exam. So after our lesson next period, you should be able to get a 65 on the physics Regents without knowing any physics. Okay, just knowing how to use this method will get you the 65. Okay, so it's a really important lesson to learn. Okay, let's get started with section E. So we're going to head to our notes. Section E, let's close up our packet, though we do not need it now. Section E is about algebraic manipulation. Algebraic manipulation. And what we're going to learn how to do today, and that you'll be quizzed on Monday, is basically a review of how to algebraically solve equations for any variable that's listed in those equations. So that means, for example, if I gave you the equation, which I think you're familiar with, y equals mx plus b, right now it's already solved for y. Could you move it around so it was solved for m? Could you move it around so it was solved for x? And could you move it around to get an equation for b? That's what we're looking at. Okay, moving everything around to develop other equations. So the letters, we're not changing any of the letters. We're just moving them to the appropriate locations to isolate the variable in question. And this is important because without doing this, we end up making significant mistakes on our problem-solving method that we're going to learn about next period. And you end up not being able to get the 65 because you're making math errors, not following order of operations. So let's talk about how we do algebraic manipulation and review how this is done. We use algebraic manipulation, as I mentioned, to solve equations that are given to us for unknown variables. And when we look at our physics reference table, which has 6 pages, 3 of those 6 pages are equations. There are a lot of equations that we solve in this course for different unknown variables. So can we all take a look at this for a minute? In your physics reference table, which you had yesterday, we say that the equations begin on page 4, dealing with electricity. Then we have equations on page 5, dealing with the topics of waves, modern physics, geometry, and trigonometry. And then we have a bunch of equations on page 6, dealing with the topic of mechanics. Now, you don't need to know what those topics refer to, and right now you don't need to know what any of those variables mean. You just need to know their letters. And what we want to be able to do is take any equation that we see on those 3 pages and move them around for the other letters in that equation. So for example, let's look at page 6. If I were to look at the very first equation on the top of page 6, we would see that that equation is a v with a line over it. We call that v bar equals d over t. Right now it's solved for v bar. Could you move it around to solve it for d? Could you move it around to solve it for t? That's what you're tasked with doing today, learning how to do that, okay? So why are we doing this? As I mentioned, it's easier to actually move the variables around without numbers and units before we sub things in, because as you will see, all of the numbers we have are not just numbers, they're measurements, and every measurement has an attached unit. And where students tend to fumble when they're solving physics problems is with moving things around with the number and the attached unit. They're okay moving numbers around, but as soon as you put a unit on it, boom, now it becomes really cluttered and difficult to move around for some reason. So we are not going to do that. We're just going to do it with a simple single letter to move from one side of the equation to the other. And the way we do this is by using a series of opposite operations to move the variables from one side of the equation to the other. Now let's just review what the order of operations is. Oh, I'm not going to use the chalkboard because I'm tired of washing my hands all day with chalk dust. So I'm going to shift to my document camera for a little bit. Let you get that down first. All right, so here we are. Do you remember what the order of operations is with numbers? Sometimes you learn a phrase in math to help you remember what you do first when you see the numbers in the equation to solve. Yep. PEMDAS, yeah, or please excuse my dear Aunt Sally. That's how I first learned it. Please excuse my dear Aunt Sally, or PEMDAS. PEMDAS is the order of operations that you use to solve for a numerical value. Now, as I mentioned, we're not going to have any numerical values. Not at this point. You're just going to have all these variable letters, which means to get them to the other side of the equation, you actually do the reverse order. Oh my goodness, this pencil is driving me nuts today already. We're going to use the reverse order for algebraic manipulation, which I call SADMEP. SADMEP. SADMEP, the exact opposite. So what does that mean? If we have the numbers and we're just trying to go to the calculator to do it, we have to remember that we're going to do everything inside the parentheses first. Then if there are any exponents, we take care of that. Then if there's any multiplication, we do that. Then if there's any division between the numbers, we do that. We go from left to right in the equation. Then if there's any addition or subtraction, we tackle those, again, from left to right. But if I'm doing this to solve for an algebraic variable, I have to do it in the opposite order, which means I need to undo any additions or subtractions first from left to right. Then I would tackle any divisions or multiplications doing the opposite of those. Then I would undo the exponents, and then I would undo the parentheses in that order. Okay, we always start the inside and we work our way out, in other words. Okay, so let's just tackle this with an example, okay? The first equation I want us to solve is y equals mx plus b. And we're going to solve it for the variable x. We want to solve it for this x. So if I think about SADMEP, the first thing I want to look for, are there any subtractions or additions in this equation? And the answer is yes, right there, which means I have to do the opposite of addition, which is subtraction. We subtract b from both sides. Screw that pencil. I'm going to subtract b from both sides, leaving me with y minus b equals mx. Now, we reviewed yesterday that when I see mx like that, there's a mathematical operation assumed to be between them. What is that mathematical operation? Multiplication. So I have to do the reverse, the opposite of multiplication, which is division. I need to keep the x where it is. So we are going to divide both sides by the letter m, leaving us with the equation that x equals y minus b over m. Okay, that's our first example. And I expect that you can show me those steps, at least right now. Yesterday, we discussed that we need to be able to walk before we can run. I need to see those steps to make sure you can walk before I let you run and skip them. Okay, let's now look at a second example. Let's take this equation, which is a physics equation, and it's read D equals V subscript I times T plus 1/2 A times T squared. and we want to solve it for the variable v subscript I. Vi is one thing, one variable. Now, one thing you're going to see me do when I write these equations is I make my lowercase t's and my plus signs look different. If I don't do that, I have a problem. I'm not going to be sure which is the t and which is a plus. You follow what I'm saying? So you'll actually see me when I write them. Do you see how my t's look different than my addition signs? That's a trick that I have learned over the number of years I've been working with physics since, geez, I took my first physics course in 1988. Since then, to make sure I do this correctly. So the first thing I have to do, again, thinking about SADMAP, is I have to undo anything that is subtracted or added. This is one term in the equation, and it's being added in. I can subtract the entire thing at once from both sides. So that is now gone from the right side of the equation, leaving me with d minus 1/2 a t squared is equal to v subscript I times t. So to keep the vi where it is, what do I have to do now? Yeah, divide both sides by t. So I'm left with the equation v subscript I is equal to d minus 1/2 a t squared all over t. Okay. Does this kind of stuff sound familiar to you? Okay. I know it's part of the Algebra 1 curriculum where they have you do this stuff. Let's now look at this equation. This is another physics equation written as VF or V subscript F squared. So VF is one variable equals V subscript I squared. Again, VI is one variable plus 2AD. And I would like us to solve that for the variable VI. Here it is. All right, we're going to solve that for the variable VI. So again, let's think about SADMAP. I see an addition sign here, which means I have to undo this whole thing first. This is one term. I subtract all of it at once from both sides. Reverse of addition is subtraction. That gets rid of all of that on the right-hand side, leaving me with VF squared minus 2AD is VI squared. Now, I don't want VI squared. I told you to solve it for VI. How do we undo that square? Yeah, take the square root of both sides. Leaving us with the equation VI is equal to VF squared minus 2AD, but all of that is under the radical. We do not simplify it any further. That is the final answer. I know some students want to try to distribute the square root through that. That is actually incorrect math. Okay, this entire thing is not a perfect square, so you can't do that. You have to leave it as it is. Okay, any questions on that? All right, I think that's the end of that presentation. Let me just double check that I have nothing else on this one. Yeah, I don't. Okay, so could you please go into your packet? And in your packet, we're going to try a bunch of these now. Page 10 is where I'd like you to turn. On page 10, we have 5 equations, and on page 11, there are 5 equations. I'm going to do 2 of them with you now, and then I'm going to ask you to try the others, pair up, and try it with someone else to make sure you can get them. All right, and then we'll check your work. The first one I want to do with you is number 1. Questions 1 through 5 are asking you to solve all of these variables for the lowercase r that you see in the equation. I'm choosing to do number 1 with you because it shows the r in a different position than what we're used to. It's in the denominator of a fraction. You can't solve it the way it's written. I'll tell you that right now. You cannot do it the way it's written. This is why I'm doing it as an example. Whenever the variable you want is in the denominator of a fraction, the first thing you need to do is linearize the equation, meaning get rid of the fraction. How do I get that r squared out of the denominator is my first question to you. Think about it like this, which means that we can then cross multiply to linearize this thing. And that's our first step. We would rewrite this as FE times r squared equals K times Q1 times Q2. Now it is much easier to solve for the r. What would we do first? What's the first thing we have to do? Think about SADMAP. Yep.
We have to divide FE.
Yeah, divide both sides by FE. We have to undo that multiplication that's there, leaving us with r squared equals K times Q1 times Q2 over FE. And now how do we solve it for r? Square root of both sides, leaving us with a final equation of r equals the square root of K, Q1, Q2, all over FE. Do we know what any of those variables stand for? No. Do we care right now? No. We just need to be able to move it around. That's all this is about, moving it around, giving us a new equation to work with. Let's see. What's the next one I want us to look at? The others on this page, I think you'll be able to tackle. Let's go to page 11. There, I think, are two of them here that I want to tackle with you. Yeah, let's look at number 7 first. 7 is a little tricky. 6 through 11, we're going to solve for the lowercase a in each of these equations. So in number 7, here is the a. First thing I see is an addition sign, and I know I have to undo addition, right? Here's the thing. Because the a is in the second term, a lot of students say, oh, I'm going to subtract half at squared to bring it to the other side. That would be wrong. You want to keep the a where it is. You are not going to touch that term to bring it to the other side. Instead, what we should recognize is that addition is a commutative operation, which means that 2 plus 3 is the same thing as 3 plus 2. It doesn't matter the order in which you add. So this could be rewritten as d is 1/2 at squared plus vit. You understand what I just did? I just flipped the order of the addition terms. Now, the other thing I should recognize is that the half and the t squared are both multiplying the a. Multiplication is also a commutative operation. 2 times 3 is the same as 3 times 2. Would you agree with that? They're both 6. So what I'm going to do is change the order of the addition. I'm going to move the a after the t squared. That way I see this as one term that precedes the a, and that makes it a lot easier to do the manipulation. So at this point, what I would do to solve it first is now undo the addition, right? SADMAP, I got to take care of any addition or subtraction I see first. So I'm going to subtract the VIT from both sides. Get rid of it, leaving me with a new equation, which looks like d minus VIT is 1/2 of the t squared times the a. And now it's really easy to solve for a. What would I do? What's happening between this and the a? So what's the opposite of that? Divide. And we divide by both things at the same time. They're grouped. So we divide by 1/2 t squared. So a would equal d minus VIT over 1/2 t squared. And we leave it like that. There is no reason why you need to simplify it. You do not. Just leave it as it is. Your math teacher might say, simplify it. No, I don't want you to do that. Just leave it where it is. Okay, get the variable we want isolated and you're good. I want to do one more, and that is number 10. Number 10 is an equation I think you're probably familiar with. Do you know what that's the equation of? Pythagorean theorem. It's the equation for the sides of a right triangle, where C is the hypotenuse and A and B are the legs. We want to solve this for the letter A. Can you help me with that? What should we do first? B squared. Yep, subtract B squared from both sides. So C squared minus B squared is A squared. And now what? Square root both sides. So that means I'm left with the square root of C squared minus B squared equals A. And that's the final answer. Some students say, oh, I'll distribute the square root to both terms. You can't do that. Think about the most common right triangle that we know of. Probably the most common Pythagorean triple is a 3, 4, 5 right triangle. Have you heard of that one before? Okay, so if this means this is A, this is B, this is C. So if C squared minus B squared, that square root is A, some students ask, well, does that mean C minus B equals A? Let's think about it. Side C would be 5, B is 4, A is 3. Does that check out? No, because 1 does not equal 3. So that means you have to leave it in that form. It only works with the squares. This is not a perfect square. Okay, that's the only way it would work if it did. Okay, questions for me? All right, I want you to try the others right now with a partner. Partner up if you have someone sitting next to you, or you can work in a group of 3 if you need to because you don't have someone next to you. So Vince, you can partner with Gianna and Ryan. There, okay? And then we'll check your answers in a minute. Get the rest done, 1 through 11. Show your steps, 1 through 11. And if you're getting really stuck and your partner doesn't know how to do it either, let me know and I'll come over and work with you. If you finish all of them, you can then start working on the homework while we wait for everybody. Yep, I got them all done. So I'm just now waiting for all of you to go. Doesn't mean you have to be as fast as me. I'd rather you be careful getting it correct. Should be able to do it quickly. I'm teaching this for a long time. And I know a lot of you are in advanced math, so you probably can do it quicker than others who are not. And that's all right too. The objective is not to be fast, it's to be correct in our work. You can go ahead and take your break. On the other side of the break, we'll go over those questions. If you need to use the restroom, now would be the time to do that. Those of you who are juniors will be calling you down for your scholars breakfast. I know who you are that are supposed to be going. There's a few of you in here that should have received an email invitation. But they'll call you down when they're ready for you. Do you want it? If you're not sure if you're going down, I have your name on a list if you're going or not. But they'll call you down, right? We're not going down yet. They didn't call down
Transfer from
Pure homeschool? Well, I was on the homeschool. Yeah.
You could be taking online classes.
Yeah.
Yeah, my friend pulled that for
A lot of them do get like guidance from certain colleges.
Yeah. So the one circle in red. Okay.
Okay, I want to see that I got my
Honestly, I didn't do it. You just had to leave when it's bad.
Oh, they're so full. And they're rude. I got
Yeah,
Brian, I got looked at that scholarship.
heck no, I got 93. It's because it's young.
Wow, that's great. I can do salary.
Dude, I might go for like half the period. That's the one.
I lose them all. I think it's Yeah, the beginning of sophomore year, I was not long. We have some there fourth quarter, I got 94. And then but that there I did
No, the whole thing.
then what do you want? Yeah, I don't care. Like I had this dirty. That's a lot. I'm like reading. Like I'm good with history though. Yeah. History's good at history. I don't
So if we go to the Star breakfast, who's gonna miss the one?
I'm sorry. 1F, yeah, so you'll have to watch the video
Okay.
for the rest of what you're going to miss so you can get caught up. Otherwise, finishing the lab on Monday will be really hard. You don't want that to happen. Remember, the next one is the secret to the 65 honor regents.
The next one?
This what you're going to miss. Yep. You will. But hey, you're a scholar. You should be able to catch up. Watch me do it with the class on a video versus being here live. That's okay. All right. So they haven't called the juniors down yet. So let's just keep going. Let's check over those answers to those 11 questions. Okay. Make sure you know what you're doing. Well, not all 11. I already did 3 of them with you. So 8 more. So let's check number 2 first. Number 2, we should have divided both sides by pi first, giving us a over pi is r squared. Then you take the square root of both sides, giving you the square root of a over pi equals r. If you got it right, give yourself a star. Number 3, this is the circumference of a circle equation. We're going to divide both sides by 2 pi. That cancels out, leaving us with c over 2 pi equals r. If you got it right, give yourself a star. If you have questions as I'm going over it, let me know. Okay. Number 4, this is very similar to the first equation, except the letters are different, but it's set up the same way. So the first thing you have to do is the cross multiplication, giving us FG times R squared is capital G M1 M2. Now I'm going to divide both sides by FG, giving me R squared is the square root of capital G M1 M2 over FG. Now I'll take the square root of both sides, giving me R is the square root of capital G M1 M2 over FG. Please make sure when you write this radical sign that it is big enough that all of that is underneath the radical.
Good morning again, Colony.
You got that right? Go ahead and give yourself a
I
star.
am announcing for the Scholars Breakfast. This is for juniors.
Hold on.
If you received the invitation in an email, you are a junior scholar. You must have that invitation. Please proceed right now to the main cafeteria.
So those
Thank you.
students I have are Shelly, Haley, Kiara, Janicia, Ryder, Alexander, and Nikolai. Okay. All right, so you folks are expected to watch the video to catch up on what you missed this period. I will see you on Monday. Let's keep going then. Question number 5. We want the variable r, but it's in the denominator. So we have to cross multiply first, giving us ACR is v squared. Then we divide both sides by AC, giving us r equals v squared divided by AC. If you have that correct, go ahead and give yourself a star. All right, ready for the next page? Okay. Number 6. I want you now to solve this for A. Since A is in the second term, I'm going to move it around. So it's VF is AT plus VI. Then I'm going to subtract VI from both sides. That gives me VF minus VI is AT. Then I divide both sides by T, giving me VF minus VI all over T is equal to A. If you have that correct, give yourself a star. Okay, we did 7 together, so I'm going to skip that one. Let's go to number 8. VF squared is VI squared plus 2AD. So that first thing I'm going to do is move it around. So VF squared is the quantity 2D times A, regroup it so the A is not in the middle of things, it's at the end, plus the VI squared. So I can see that I'm going to subtract the VI squared first, giving me VF squared minus VI squared is the quantity 2D times A. Now I can divide both sides by 2D, giving me VF squared minus VI squared all over 2D is equal to A. If you got that correct, give yourself the star. If you did not, correct it so you have the correct solution. Number 9, we're just going to divide both sides by M, leaving us with F divided by M is equal to A. Number 10, oh, if you got that right, of course, star. 10 I did with you, so let's move on to the last one, number 11. I just need to multiply both sides by C. Opposite of division on the right side is multiplication, leaving me with C times the sine of theta is equal to A. If you got that right, give yourself a star. Any questions? How did you do? Good. Good. So your assignment this weekend is just to practice more of this on the next page. Make sure you're comfortable with it before I give you 3 equations to actually do on Monday. Monday's quiz is not on the Chromebook. It's on paper. You have to show me your steps. So if you're not showing the steps correctly, you're not going to get the point for that one being solved properly. But if you show the steps, you should be okay. All right, let's now go to the lesson on problem solving. So back to our notes, please. Problem solving, section F, which we're going to practice a little bit in class today. But remember, we're going to be using this on lab number 1 when we finish that on Monday. And you may also want to think of it as our secret to getting the 65 on a Regents exam. We still need all of those things that are up on the chalkboard for our lesson today. Problem solving. All right, we ready? Okay, here's what I expect you can do with this. And this will not be quizzed on its own. It's quizzed in terms of the lab, and then we'll be using it all the time once we get into the real physics content of the course. So you would have to be able to list and correctly use the 7 steps we have in our problem solving method, and then solve word problems using the 7-step method I'm going to teach you and your reference table. That's what I expect you to be able to do. Okay. And then we're going to learn something called dimensional analysis, although I'm not going to tackle that today. I will tackle that once we get to the physics stuff, which we use to verify that units on our answer match the units given in the problem. All right, so let's talk about the method. The first step in the problem solving method, I told you there are 7 steps. The first step is to list all the given measurements in the problem. And you'll see how we do that in a moment. Notice that the word in red, I'm going to turn off the light so you can see it a little bit better. The word highlighted in red starts with a G. Okay, that's going to be important. We're going to learn a word to help us remember this method. Notice it starts with a G. We're going to list our givens. Then the next thing we do is we list the unknown as a variable. So we try to figure out when we read the question, what is it that we're being asked to solve for? That's our unknown. What letter does unknown start with? U. Okay, so we have a G and a U. The next step is to list an equation to use. And where are we going to find that equation? On our reference table. Basically, we're going to go like equation shopping. Find an equation that contains all the given measurements and the unknown variable. We'll then write that equation. What letter does equation start with? E. G-U-E. We're building a word as we go through. G-U-E. Now, the next step is not in the word that we're building. It's the process I just told you that we're going to do is we're going to do the algebraic manipulation. Move that equation around so it is solved for the unknown variable that you're trying to find. Isolate the variable that we want to solve for. Do the algebraic manipulation. Now, that is not a requirement for the Regents exam, but it does ensure that you're getting the question correct. meaning you're coming up with the correct answer. I have found if when students don't, they skip that step, they skip step 4, that most of the time they make mistakes mathematically. Okay, so I'm trying to build in some safety nets to make sure we can get as many points as possible on your final exam. Number 5, step 5 is then to substitute in the given measurements, including their units, into the equation that you developed when you isolated the unknown variable. So we say substitute or sub in. Sub starts with an S. So again, we're building in creating this word, GUES. The 6th step is to then plug it into your calculator and solve it. Get an answer that has appropriate units and significant figures. Notice that the word solve also starts with an S. We just built a word. What word did we just build? Guess. That's the method. It's called the guess method. It doesn't mean I want you to take a guess on your answer. It means every letter is a letter in the process. Now, I did say it was 7 steps, right? The 7th step is to perform a check. Do a check. So like the guess check method. Does the unit of the answer match the units in the problem? And we call that dimensional analysis. That term shows up frequently on Regents exams. They won't say check your work. They're going to say use dimensional analysis to show that the units of the force equal the units of mass times acceleration. So it's the process that I'm going to teach you that they will be testing you on. And you have to know it by name. So the guess check method. All right, so now we're going to learn how to read our reference table and not know any physics to solve physics problems. You're going to solve 5 physics problems with me now without knowing any physics. Remember, this is the secret to getting a 65 on the Regents, being able to do this. So make sure you got your reference table out. Can I turn on a set of lights again? Yes, okay. Sorry. Great. Let's then turn to page 13 in your packet, because I think no, we're not going to do that one. There's another example in the presentation, but we're going to go right to these here on page 13. Just make sure I'm sharing the right stuff. Yep. Okay, so I'm going to do the first one for you. And then we're going to start going around the room so everybody can take one step of the process. So notice that the directions to these problems are to use the problem-solving method and your reference tables to solve each of the following problems. We're going to show all our work. When I say that, that means I want you to use the guess method. And then don't forget, we want to pay attention to the significant figures on our answers. All right, so let's look at question number 1. First thing we need to do is just read it. It says, in an electrical circuit, a voltage of 120 capital V is applied to produce a current of 5.0 capital A. What is the resistance of the circuit? Okay, now we just read it. Right now, you should see that there are 2 measurements given to you in the problem. You see them? Don't even care what they are. We're going to circle the value with the unit. I'm trying to help you decode these word problems because some of them get rather long. Some of them are embedded in a paragraph. I want you to figure out how to simplify it for yourself because that is often the trickiest part of physics. So we see these are the 2 values, measurements that are being given to us. The next thing I want us to do is to underline the word that you're being asked to solve for. The physical quantity that you're being asked to solve for is something called resistance. Do you see that? It says, what is the resistance? Okay. Now we're going to start making our list of givens. And we're going to use the letter G. We're going to put these letters in the guess method with the steps. Eventually, you don't have to do that. But again, I'm trying to help you walk before you run. So you're not tripping on yourself. The first thing we see is that we have this value, but we got to figure out where on our reference table we're going to look for these equations and variables. So when we look at the equations, remember that the equations begin, you've got your reference table there. So they start on page 4. And when we look at our reference table, we have headings of electricity, waves, modern physics, geometry and trigonometry, and then everything else is called mechanics. Based on the wording of this question, which section of the reference table do you feel is probably the most appropriate section we're going to use? One? Yeah, right. It says electrical circuit. There's electricity in here. So we have to use a little bit of reading comprehension to help us figure out which page of the reference table we're going to work with. So right now we all need to turn to page 4. Now I'm going to teach you how to read this. The first value says it is a voltage. Do you see that? Voltage of this. That means this measurement is something called a voltage in physics. What I would like you to do, looking here at page 4, on the left we have equations. Don't even worry about those yet. You got to go to the right-hand column. In the right-hand column, we define for you what every variable letter stands for. So we're looking for something right now called a voltage. So look at that list. Do you see anything on this list which is identified as a voltage? Take a look. You have it in front of you, right? Do you see the word voltage anywhere on page 4? Where? Does it say voltage? V-O-L-T-A-G-E. Do you see that anywhere on the page? No, it's not there. Okay, so this is where when we study physics, you will learn that a potential difference is also called a voltage. For now, go ahead and write that in there. This reference table is going to become notes for you. A potential difference is also called a voltage. Now that we know voltage is potential difference, we see that we identify that variable with a capital V. So anytime we see capital V by itself, we know that means voltage. So what we do in our givens list is we say that capital V is this measurement, which is 120 capital V's. All right, what is this a measurement of? The 5.0 capital A's. It says that is a current. Okay, so same thing. Go back to your reference table. What letter do we use to stand for a current? Yeah, capital I. I want you to be specific whether it's uppercase or lowercase because we use both, but they mean different things. And this is why I need to make sure when you write your letters down that you're using the appropriate upper or lowercase. If you wrote a lowercase I instead of a capital I have to mark it wrong because a lowercase I stands for something else in physics. Okay, I'm not trying to be picky about penmanship, but I have to be. You need to know the difference between an uppercase and a lowercase and write it exactly as it's shown to you. Okay, so this is a capital I. Current is capital I, so we're going to write capital I has a value of 5.0 A. That's it for our givens. The next letter U stands for the unknown. We said that what we were looking for, what was unknown, is the resistance. According to page 4 of your reference table, what letter are we going to use for resistance? Capital R. Okay, now we go to the next letter, E. What does E stand for? Yes, good. E stands for the equation. So here's what we're now going to do. We know we have the letter V, the I, and the R. Now we go to the left side of the reference table. Here are the equations we can pick from. We need an equation which has a V, an I, and an R, and that's it. You see an equation which has those three letters. Ryan, what is it? Equals. There. Yeah, this one right here. R equals capital V over capital I. Let's write that. The next step is to see, it's not part of the word guess, is this solved for the unknown letter? Is the equation written for the unknown letter? It is. It's already solved for R, so we can go right to the first S, which stands for substitute in your given measurements. Let me show you how we do that. We keep the R, because that's what we're looking for. Instead of V, we put the entire measurement with the unit, 120 Vs. Instead of the I, we put its measurement with the unit, 5.0 capital A. The last S in the word guess stands for solve it, which means now you go to your calculator. Since these measurements are not in scientific notation, we don't want the scientific mode on our calculator. So get your calculator out of the scientific mode and now go ahead and solve it. And what does your calculator give you as your answer? Yep, 24. So we're going to say the last S step is that R equals 24. Now we have to put a unit on it. We don't know what the units of R are in physics. We don't need to. Instead, we're just going to show the units that we plugged in the mathematical form that they are. In other words, this would be measured in capital V over capital A. You see what I just did? I just carry them over. Now, the last thing you have to do is check the sig figs on this. 120 has how many sig figs? 2. Without the decimal point, absent, there's 2. How many does 5.0 have? 2. So how many sig figs do I need on my answer? Does that have 2 sig figs? Yep. So we're going to box that in as our final answer. The last step is to do the check. I'll show you how to do that. The dimensional analysis. We start by rewriting our equation. R equals V over I. But all we are doing is checking the units that we came up with. The units for R that we came up with were V over A. We're plugging in the V over A for the R. Those were the units we got for R, V over A. What units was V measured in? V's. What unit was I measured in? Capital A. Do the left and right sides equal each other? So it checks, and that problem is now done. That is how a physics problem is solved. That's the secret to the 65. If you can do all of that, you can get your 65 without knowing any physics. Well, we had to know one little piece of physics, understanding that voltage was potential difference. That's what the whole rest of the other 35 points on the exam are. Do you know the terms? Do you know some of the concepts? Let's go to number 2. Who wants to read the question? That was the very first thing I did. Go ahead, Chaudhry.
Wave has a frequency of 5.0 times 10 to the 14 hz, and wavelength of 6.0 times 10 to the negative 7 meters. What is the speed of this wave?
Okay, so we just read it. Juan, can you tell me one of the measurements I'm being given that I should be circling in the problem?
Frequency.
The measurement value. The value.
5.0 times 10 to 14.
HC. We're going to circle that. That is the measurement value with the unit. Devin, can you tell me what the second measurement is that I should be circling?
6.0 times 10 to the negative 7.
Very good. Now we go to the word for what we're looking for. And Jacob, can you tell me what we're looking for? What word? Speed. We underline that word. We're looking for speed. Okay, now we got to figure out which page, which heading do you think this problem comes under? Do you think it's electricity, waves, modern physics, geometry and trigonometry, or page 6 is mechanics? Ryan, what do you think? Yeah, it says wave. Little bit of reading comprehension. It talks about a wave. It's probably on the wave section. Very good. See, this is not rocket science, okay? It's on waves. So now we got to look up the letter or the variable letter that we're going to use for this measurement. Notice it says in the question that is a frequency. So look at this section, look at the right-hand side. Gianna, can you tell me what letter they want us to use for frequency? Just the right-hand column here. Which one is identified as frequency? Okay, go to the waves page, my dear. There you go. F. F is frequency. So we're going to say that F is this measurement, 5.0 times 10 to the 14 Hz. Vincent, what do they tell you this is a measurement of? Wavelength. Can you try to describe what the symbol for wavelength looks like? Yeah, I would call that like an upside down Y. This is a Greek letter called lambda. It's a Greek letter we're going to learn about later. It's a Greek letter lambda. It's an upside down Y. That is the symbol for wavelength. We're going to write 6.0 times 10 to the negative 7 M. All right, next thing we got to do is our unknown, the U. We are looking for the letter that stands for speed. Sydney, can you tell me what letter we're going to use for speed? It's a V. That's right. It says V is a velocity or a speed. So V. All right, now we got to find an equation. So we need an equation on this waves page, which has the F, the lambda, and the V. Miriam, do you see it? Okay, so go ahead and read that to me. What is it?
E equals F and wavelength.
Yep, lambda. Lamb, like the animal, and then da. Lambda. DA at the end. Okay, we have to ask ourselves, is the V isolated in this equation? Yep, no algebra to do. Yay. Next step is the first S, which stands for substitute in your measurements with their units. The frequency is 5.0 times 10 to the 14 Hz. And the wavelength lambda is 6.0 times 10 to the negative 7 M. Okay, hold on a minute. These measurements are given to you in what form? Scientific notation. So guess what you need to do on your calculator? Sci mode. You got to put it back into the scientific mode. You're going to be going back and forth all year. Put it in the Sci mode. Type these measurements in using proper scientific notation with the E key, and let's see what we get for our answer. Gavin, do you have an answer from the calculator? Yes. Okay. Now let's talk about sig figs. Flavia, how many sig figs does the first measurement have? Yep. Emma, how many does the second measurement have? 2. So that means I need how many on the answer? I need 2. That only has 1. How do I write it so it has 2 sig figs? Do you think you know there, Blake? Yep, 3.0. So now I have the proper sig figs on the answer. That's good. And now the units. We're just going to keep what we had. This times that. So an HZ times an M. And there's our answer. What's the very last thing I have to do? Check it. I want to check that the units match, that I have correct units for this equation V equals F lambda. The units of V were HZ times M. The unit of frequency was Hz. The unit of the wavelength was M. Does the left equal the right? Yeah. Are they always going to be this easy on the check? No. But right now, I'm going to give you the easy ones because we don't know all the other physics that's involved to change units from one thing to another. Questions on 2? Right, you ready to try 3? All right. So, Jackson, can you read number 3 for us, please? Yep, 100 point kg. That point is going to be important for sig figs when we get there. So, Khalees, can you help me out? What measurement should I circle in this problem? Yep, the 100 point kg. Maxwell, what word should I underline that I'm looking for? Correct. That's it. Okay, now we have to figure out which page of the reference table or which section we're looking at. This isn't electricity. There's nothing about currents or circuits or anything like that. I don't see any mention of a wave, so it's probably not that. So it could be modern. Is this geometry? Do you see any geometric shapes or triangles? No, it's not that. Or maybe it's mechanics, but Albert Einstein is a fairly recent scientist in terms of physics. Physics goes all the way back to the 14 and 1500s. Einstein's fairly recent with the 20th century. So, Elisa, what section do you think it's probably in? Modern. That's right. This is a modern physics problem. All right, so let's get started. We said that this was a mass. So, Chaudhry, what letter am I going to write to go with the 100 point kg? Looking at the modern physics section, what letter represents a mass? M, lowercase m, is equal to 100 point kg. All right, Juan, now let's go to the unknown. Leave a little space between that and this because there is another one that we're going to get, and I'll show you where that is in a minute. Capital E, very good. All right, let's go to our equation step. Devin, I need an equation under modern physics that has the little m and the capital E. There's only one there that has a little m and a capital E. What is it? Yeah, probably the most famous physics equation ever that was developed by Albert Einstein. Now, notice that I can't quite solve it yet. The algebra is done. It's already solved for E. But I need to know something else in order to solve it. What else do I need to know here, Jacob? I need to know what C is, right? Okay, now according to the modern physics section, what does it say C stands for? Okay, the speed of light in a vacuum is a constant value that scientists have already determined. On page 1 of your reference table, there is a chart of measurements that other scientists have already determined. Do you see that value in that chart on page 1, the speed of light in a vacuum? Ryan, do you see it? Page 1 has a chart of physical constants. These are measurements that have been made by other scientists. We're looking for the value for little c, the speed of light in a vacuum. Yep. That's a meter per second. So we're going to list that as a given. We don't have to give you every measurement if other scientists have already made the measurement and it's on your reference table. These are the only measurements that you're ever going to need to look up. They're right here. There's relatively few in comparison to other subjects. So that's where we'll get it. We already said it's isolated for E, so we don't have to do the algebraic manipulation. We can go to the first S, which is substitute in the given measurements. So capital E is equal to 100 kg times the quantity 3.00 times 10 to the 8 m over s, and we're going to square that value. Please surround that measurement with parentheses because that square applies not only to the number, it also applies to the units. Now you're going to go to your calculator and you're going to solve it. Since we have one number in scientific notation, you want to be in the SCI mode on your calculator. Gianna, do you have an answer for me? Okay, we'll get to the units in a minute. Let's do sig figs first. Vincent, how many sig figs on 100 point? Yep. Sydney, how many sig figs on 3.00 times 10 to the 8? 3. Yep, we only look at the coefficient, so I need 3. Right now, the calculator's only giving me 1. So Miriam, can you write that so it has 3 sig figs? Correct, times 10 to the 18. Now the units, we're going to keep the kg. But remember what I said about the square? The square gets distributed to the number and the units. If I square m over s, that squares the m in the top and the s in the bottom. So that gives me a kg times an m squared over an s squared. This one, the check, is a little trickier. Let me work it through with you. We are going to check E equals mc squared's equations. We said that E is in kg times m squared over s squared. M is in kg. Now C is in m over s, right? We have that as m over s. You are writing all this down, right? This is not something that I'm just doing for me. I learned how to do this a long time ago. I don't need to do it for me. I'm showing you how to do it so when you are asked to do it on a test, a quiz, the Regents exam, you are prepared to get all of the points because these are like worth a lot of points on a question doing this step. Khalees? The C came from here on page 1 of my reference table. Speed of light in a vacuum, given to us right here. Okay. Okay, so did you forget the square at the end? So you should have typed it in like this, 100 times 3.00 E8 with the square at the end. Is that what you did? Okay. Okay, so now let's worry about how, does the left look exactly like the right? No, so here we have to do a little more work is what I was indicating before. Keep the left as it is. Our job is to show how the right becomes what's on the left. We have to square this out. When I square an m over s, what do I get? M squared over s squared. That now checks. Okay, so there was one additional step that we didn't have in the other problems. Are we good so far? Yes? Okay, let's go on to number 4. So, Gavin, can you read number 4 for us, please? Okay. So, Flavia, what should I circle as a given measurement? 2.0 m, that's right. Emma, what should I underline that I'm looking for? Yeah, and I'm going to actually say area of a circle because there's multiple areas on our reference table. So which section of the reference table do you think we're going to work with, Blake? Yeah, the geometry section. It's a geometry problem. Geometry down here. And notice it's broken down into different shapes. That's why I said area of a circle. We're going to look at the circle subset of equations. And over here are the list of variables. So let's start off with our givens. This 2.0 m, Jackson, is a measurement of the what? Yeah, the radius. So when I look at the list of variables here, what letter are we going to use for that? R, little r. Lowercase r is 2.0 m. All right, now we have to go to our unknown. I need a variable letter for the area of a circle. All right, we're out of time. We'll finish this up on Monday. Have a wonderful day. Don't forget to finish page 12 for your homework.